Hey, before we get started today, I just want to let you know I have a news flash to share with you. First things first, the test over this unit, circles, will be on December the 19th. Fortunately, that's before our holiday break, so you'll have time to just relax and enjoy yourself over break, and of course, plan for that semester final that's coming the 15th and 16th of January, but we'll talk about that another day. Anyway, this week's assignments are located in Google Classroom, and they're numbered day 1 through day 4, so please make sure that you're getting those completed. Seem to be very easy for everyone. Just putting out about 5, 6 problems for you, so you should be able to get them done without a lot of effort. Also, students have been telling me that Delta Math assignment that's due on Friday is really, really easy. So get online and please just get it done so I can give you those points right away. The last bit of news flash that I need to share with you is that we've decided that we will be playing Let's Make a Deal with our final exam this semester, which is a very exciting thing. Can help make the semester end on a very positive note for everyone in the class. So we'll share more information with you about that on Monday. A few students have been hearing about it, so if they want to share, that's great. Otherwise, we'll talk to everyone on Monday. Today, as we go through the lesson, I would appreciate it if you get your notebook out, and when I ask you to think about stuff or write things down, or what are your thoughts, just jot a note or two, if you will, or draw a picture so you can show me what you were thinking and maybe what the class was thinking. But anyway, keep your notebook out, keep it handy, keep a pencil preferably handy, so you can just jot down your thoughts as we go through today's lesson. Here we go. Today is Wednesday, December the 4th, and our learning target is to explore lines. So we're going to do some more exploration, but we're exploring lines that intersect a circle at just one point. And a special name for that kind of line. And students will be able to use a relationship between tangent lines and radii, which is again plural for radius, to prove, using words and other representations, a theorem about circumscribed angles. Again, your assignment is Cumulative Review Day 3 worksheet. And please know that even though I'm not there with you, you can do this. Yes, you can. Again, our focus right now is on circles, Unit 4, and today is December the 4th. Get those notebooks out, get ready to go. You will need your Chromebooks as well at some point, so you can have those out to use if you choose. Circle Lesson 3, Tangent Lines. Again, December 4th, we're going to be using relationships between tangent lines and the radii to prove the theorem about circumscribed angles. Just a nice graphic that shows some information that you guys, most of it you know, some of it you'll be focusing on today as well. Okay, we start by swimming to the shore. This is our warm-up, and we want to look at the graphic that's there and note that line L is representing a straight part of the shoreline at a beach. And suppose you are in the ocean at point C, so you're out in the water, and you want to get to shore as fast as possible. Assume there's no current, so you don't have to worry about drifting off here or there. And note that segments CJ and CD represent two possible paths to get you to that beach. Diego says, hey, no matter where we put point D, the Pythagorean theorem tells us that segment CJ is shorter than segment CD. So, segment CJ represents the shortest path to the shore. Here's where you need to start writing or thinking. 27 seconds. Do you agree with Diego? And explain your reasoning. Now here's that picture again without our lines on it, and note that there are many possible paths from your location out here in the ocean to the beach. And so there are many possible distances between point C and line L. So if someone asks how far away you are from the shore, what do they really mean? You can jot that down in your notes. What do they really mean when they say that? How far are you? And what does Diego's reasoning tell us about the shortest path from any point to any line? Okay, let's take a look at a particular perpendicular. So a tangent, a line that's tangent to a circle, intersects the circle in exactly one point. And I bet some of you have already figured that out from just the definitions of what we're doing for today. I would like you to name a tangent, any tangent lines that you see in this diagram, and you can number on your paper, put 3.2 and then number 1, and please write down the name of that tangent line. And remember, lines are named using 2 points. And then answer question number 2, why isn't line PQ a tangent line? And why isn't segment ON a tangent line? If you need to pause the video to write down your answers, that's just great. Now, we are going to do an activity, and this activity, you get a choice. You can either choose to use GeoGebra, the GeoGebra link. It is below in the document here. It's also listed in Google Classroom under Wednesday, and you can use that, or you can use a compass and a ruler with the paper. You should have paper available in class today that has a picture of a circle on it, and you're going to follow the directions listed here. Please note that it's going to be a little bit different for those of you that are on GeoGebra, because there's no way to label the figure. But the first thing you're going to do is get yourself prepared and pause the video if you need to until you're ready to get started with GeoGebra, or you have that paper in front of you. Okay, now that we're ready to move on, the first thing you're going to do is draw a radius in the circle, and it can be anywhere. For those of you using GeoGebra, it's already there for you, and it's pink. So use that pink point and draw your radius between the center of the circle out to that point. You want to mark the point, those of you using paper, mark the point where the radius intersects the circle and label it point A. Next, using any means you can, I want you to construct a line perpendicular to the radius that goes through point A, and label this line with a cursive N. Those of you who have GeoGebra, there's a little direction on there that says once you get this drawn, use the angle measure tool and see how close you are. See how close you are to getting that perpendicular, and just remind yourself what it means to be perpendicular. Those of you in the class, remind each other, what does it mean to be perpendicular? And if you don't remember, you have a Chromebook in front of you. You can get on it and do a Google search for the word perpendicular. Then number 3, line N intersects the circle in exactly one point, A. And I want you to answer this question in your notebook. Why is it impossible for line N to intersect the circle in more than one point? And then number 4, so what kind of line did we make when we made line N? Here's examples of what your sketches might look like. This one on paper, it might look like this on paper, and the one, those of you using GeoGebra, it might look like this. Now, I got really close, 89.4. Hopefully you get even closer and can get it all the way to 90 degrees. But these are examples of what it might look like if you did those sketches on either of those two locations. Okay, we call the point where the tangent line intersects our circle the point of tangency. And I want you to add this theorem to your notes, this theorem right here. It says a line is tangent to a circle if and only if it's perpendicular to the radius drawn to the point of tangency. So a line is tangent to a circle if and only if it is perpendicular to the radius drawn to the point of tangency. And that is a theorem. And it's a theorem because it can be proven. Again, if you have to pause the video in order to write that into your notebook, go right ahead. You can start up when you're finished. Okay, this image shows an angle whose rays are tangent to a circle. So these rays are both tangent. And you should have a piece of paper on your paper for today, the notes for today, you should have a picture of this. And on that paper, please follow these directions. You want to mark the approximate points of tangency and draw the two radii that are going to intersect these points of tangency and label the measure of the central angle formed. Just give it the letter W. This is a fancy W, guys. And then number 3 is saying, so what is the value of W plus Z? And I don't want you to give up. You think about this. Okay, these lines are tangent. We're drawing the radius. If you have to go backwards on the video to double check all this stuff we've been doing, or look at that theorem and then figure out what is the value of W plus Z, and then explain or show your reasoning, please. Now this image shows a quadrilateral with one diagonal going through it. And how can this drawing help us figure out the sum of the measures of the angles in a quadrilateral? So we're trying to figure out what is the sum of the measures of the angles in a quadrilateral. And I know some of you already know this because I remember talking about it in class a while back, and some of you already know. So, but I want you to answer this question and think about it a bit. Talk about it with your table mates there. And how can this drawing here, the way it's sketched out for us, how can it help us figure out the sum of the measures of the angles in any quadrilateral? Okay, synthesis. We're going to be putting this all together. Now, segment CD is tangent to the circle at point B, and I would like you to find as many right angles as you can in the diagram and explain why they have to be right angles. Okay, always give an explanation. Again, if you have to pause the video while you're locating them and while you're writing an explanation, you're more than welcome to do that. And then you should have a cool down diagram. This would be a small piece of paper like we've been doing earlier in the week. We did today and we did yesterday. And you need to, or Monday, Tuesday, I guess, and you want to make sure that you complete that cool down, put your name on the paper and turn it in. You can put it in the box that's marked with your class period 1, 2, 5, or 7, and make sure that you explain or show your reasoning for what the value of A plus C need to be. And again, A and C are talking about the measure of the angles in that triangle. Note that line BC is tangent to the circle. Okay, so you can figure out what those angle measures have to be. Not necessarily specifically, but these two together. What do they have to be? Okay, and then lesson 3 assignment, cumulative practice, day 3 worksheet, and I know you've got this. So anyway, have a great rest of your day, and we'll talk to you tomorrow for day 5, or lesson 4, and just have a great day. Talk to you later.